Hello, welcome to the EU, CNC, and 6G Summit demonstration of multi-vendor xApp scenario on Origami platform for interoperable O-RAN conflict mitigation. We will be walking through the goals, deployment, and the runtime dashboard of the NetAI xApp that was developed as a joint integration effort with IS Wireless. For this demonstration, NetAI's xApp will be optimizing physical resource block quota per slice in an interoperability scenario within a multi-vendor O-RAN environment, specifically highlighting the real-time resolution of direct conflicts between independently operating xApps. To achieve this, we will be integrating with the IS Wireless implementation of a near-real-time RIC. NetAI's xApp achieves PRB quota optimization by tracking UE throughput in both uplink and downlink directions on each slice and forecasting their values in the near future. The xApp then sends radio control requests to allocate a proportional physical resource block quota to meet the anticipated demand. For forecasts, we utilize TS mixer models trained for each slice. Inference is performed with a window of 30 steps, with both uplink and downlink UE throughput every step. The output is 10 forecast steps, which are then used to determine control actions. To deploy our xApp, we use Docker Compose to start the xApp containers. From the logs, we can observe that it has registered with the IS Wireless near real-time RIC. We can also observe that the xApp has successfully registered through the RIC dashboard. It then establishes an SDL subscription for the metrics our xApp will be following and using to make decisions about the network. Once the subscription is established, we can observe metrics incoming from the RIC. The xApp awaits until there is sufficient window of data to perform inference on. Once enough data is received, the xApp forecasts future values and generates control actions based on them. We can now move to the Grafana dashboard to better observe the xApp in action. In this demo scenario, we have one cell with 2 slices and 4 UEs connected and active. The live xApp forecasts on each slice can be seen here. On the left, we can observe the PRB quota allocation sent by the xApp, as well as the actual PRB usage per slice. Below, a counter keeps track of successful radio control requests sent by the xApp. The testbed is also running another competing xApp that is attempting to modify the same network parameter, PRB quota. To resolve conflicts, the demonstration introduces the platform for interoperable O-RAN conflict mitigation framework, part of the Origami project's global service-based architecture. By enforcing a strict priority-based strategy, the platform successfully resolves the conflicting commands by prioritizing the NetAI xApp. The current scenario shown displays conflict mitigation in action. As we can see, the PRB quota closely matches actual usage. The RIC dashboard also tracks the number of requests accepted for each xApp. In this case, the secondary xApp is at 0. For contrast, let's switch to a scenario with conflict mitigation disabled. The NetAI's xApp PRB quota constantly gets overridden by the second xApp, leading to PRB usage fluctuating wildly between slices. The RIC dashboard shows both xApps executing RC requests. In this demonstration, as part of the SNS Origami project, we have demonstrated a successful integration with the IS Wireless near real-time RIC and the interoperability of xApps from multiple vendors utilizing conflict mitigation. This concludes our presentation. Thank you for watching.